Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hi, everyone, and welcome to the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Each episode, we share the latest discoveries, observing techniques, and stories from the people who explore the moon, planets, comets, meteors, and beyond. Whether you're looking through a backyard telescope or leading professional research, we are all united under one sky. I'm Tim Robertson, your host, and thanks for being here. Now, if you're normally listening to the podcast in your car or on your phone, you can now watch it as well. That's right, the Observer's Notebook is now available in video right here on the ALPO YouTube channel. And here's another something interesting. I've noticed that over 50% of the people watching or listening are not subscribed. So take a quick second, hit that subscribe button, and ring that bell so you don't miss another episode. It's free and it really helps grow the channel. This show is made possible by support from you, our listeners. If you'd like to help the Observer's Notebook, just go to our Patreon page at www.patreon.com/observersnotebook. For $1 a month, you're supporting the show. For $5, you get early access to the podcast. For $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you're listed as a producer of the podcast. And to find out more about the ALPO, just visit www.alpo-astronomy.org, where you can join the organization for as little as $22 a year. All right, let's get into episode 231 of the Observer's Notebook podcast, and we're talking meteors. Enjoy. All right, every April, the Earth plows through a stream of ancient comet dust for a few nights, and the sky answers back with streaks of light they call the Lyrids. They're the oldest recorded meteor shower in human history, seen by skywatchers for more than 2,600 years. Every year they manage to surprise us, sometimes gentle, sometimes subtle, sometimes bursting fireballs that stop you in your tracks. Tonight we're going to talk about the Lyrid Meteor Shower, what makes it special, how to observe them, with, of course, our man, Bob Lunsford. Welcome to the podcast, Bob.
Thank you. Yes, after 3 months now of the doldrums of the Northern Hemisphere during wintertime, we finally have a meteor shower worth watching. Um, the Lyrids are active throughout the second half of April, and let's take a look at what we're dealing with. Okay. Okay. Like Tim was saying, the Lyrid Meteor Shower is an annual display of shooting stars that occurs every April when the Earth passes through the dust and debris left behind by Comet 1861 uh, Thatcher. This comet last appeared in 1861 and is not expected to return until 2276.
Oh, my.
And I don't think we're going to be around for that one. Luckily, not all the meteoroids follow the comet exactly. Um, as you'll see in an upcoming diagram of the orbits, they get perturbed by planets, so it's a mishmash of all kinds of chaotic orbits. Uh, let's discuss the Ursids as it happens every year. They're active from mid-April, roughly April 17th to 26th. The peak this year happens during the daylight hours of April 22nd. So you can watch either on the morning of the 22nd or the 23rd and pretty much see the same activity. Uh, as it says in parentheses here, most meteors are visible in the morning hours when the Lyrid radiant is high for the northern hemisphere. Uh, Luckily, this year the moon will be a waxing crescent phase and will set near midnight. allowing the more active morning hours to be free of interfering moonlight. So here's what the particles from Comet Thatcher look like in outer space. Um, the inner planets is a very tiny orbits right here.
Mhm.
The orange represents Jupiter, the green
Oh,
is Saturn. And as you can see, most of these are located very far from the inner the inner solar system. So we never really get a strong shower. Now, the particles that are roughly outside of Jupiter's orbit here, they have a much shorter orbit, say probably 12 to 15 years, than the ones out by Saturn. Um, and like I said, very few actually follow the exact orbit of the comet, mainly because these particles here have only been uh, figured out for the last 20 years or so.
hmm.
So there's probably many more way out here, but we haven't discovered though. Each one of these particles represents a Lyrid meteor that was photographed on two or more cameras.
That's crazy.
So, and their orbit was triangulated, and this is what they look like in space. Now, what you'll see from the typical Lyrid shower is normally between 10 and 20 meteors per hour under dark skies. As Tim mentioned, you'll often see fireballs from the shower. Now, you can think of fireballs, you probably think of something really large and bright, but to be honest, it only takes a meteor the size of a softball to produce a flash as bright as the full moon. So
Wow.
to be honest, all of these particles are very small. And the normal ones you see are just the size of what peas, grape nuts, something, pea gravel, something
Okay.
in that size. Now the meteors will radiate from the constellation of Lyra near the bright star Vega, but the streaks can appear any part of the sky. The best time to watch the shower is during dark, moonless hours before dawn, when the constellation Lyra climbs higher in the sky and meteor counts are strongest. You don't need a telescope, just a comfy spot and a wide sky view. It's advisable to give your eyes 20 to 30 minutes to adjust to the dark sky for best viewing. Now let's take a look how the sky looks during different portions of the night. This is the sky at 40 degrees north latitude at 10 p.m. That would be daylight time. As you can see, this circle, which represents the Lyrid radiant, it
Okay.
lies just above the northeastern horizon. So the center of the chart here represents the zenith, and we have the northern horizon here above, southern horizon below. So as you can see, uh, only those meteors shooting upwards can be seen at this time of night. Those that are shooting sideways or downward are blocked by the horizon. So this time of night, you're not going to see much activity at all. So let's go 3 hours further and see what it looks like at 1 a.m. in the morning. As you can see, the Lyrid radiant has risen higher in the sky, and now meteors can be seen in all directions. Now, you're still going to miss a few that are shooting straight down, but I would say you can see well over 50% of the meteors that occur. This would be the start of the prime time hours to uh, to start watching. This is probably about the time the moon will be setting too.
Mhm.
So it's a good time to start. Notice here, meteors that appear further from the radiant are longer, and those that are closer to the radiant are short. And the reason is that when you see a meteor close to the radiant, it's coming at you. Therefore, it's foreshortened. And the longest meteors are observed 90 degrees from the radiant. Any further than that, they start to foreshorten again.
Hmm.
And to be honest, When the radiant lies on the horizon, you can actually see very short meteors almost 180 degrees away along the southwestern horizon.
Wow.
But being that this shower is not that strong, the odds of seeing that are pretty remote. Okay, let's go to the best time of the night, which is during just before dawn at 4 a.m. Same location, 40 degrees north latitude. And here the radiant is very close to the zenith.
Oh my.
So you can see almost 100% of the meteors that are occurring right now. I should say the bright meteors, because a majority of the meteors are going to be dim no matter what the altitude is. So, but this is the prime time to observe because it's highest in the sky. You can see those fainter meteors, and there will not be any horizon to block. So, at this time of night, you can basically look in any direction and see the same amount of activity. What you don't want to do is look straight up at the radiant, though, because at that location, the air is thinnest. Therefore, the meteors only have a slight chance of appearing. We're talking what roughly 100 miles, sorry, 100 kilometers of air at the zenith. Whereas if you look closer to the horizon, you're looking through a much thicker column of air. So your best bet is probably to look halfway in the sky, anyway, anywhere that has a dark. So
Okay.
if you have, let's say, a city toward the west, look toward the east, and a tree in the south, you can look due north. But this is the prime time to look. Now, you might wonder, for folks that live in the southern hemisphere, can they see this activity? Yes, they can. Here's a map showing the sky from 25 degrees south latitude at 3 a.m. Local standard time. Most countries south of the equator don't observe daylight savings time. So here we have the Lyrid radiant. It's roughly half the altitude that we see in the north. Therefore, any meteor shooting downward will be obscured by the horizon. So if we can see 10 to 20 meteors from the northern horizon, from this particular latitude of 25 south, that's going to be cut in half probably from 5 to 10.
Okay.
Now, why are the Lyrids special? Well, as Tim mentioned, it's the oldest documented meteor shower. People have watched it for over 2,500 years. The first sighting of Lyrid meteors goes back to 687 BC by the Chinese. It's reliable every April, and the first major shower after the winter's quiet skies. And these are fast, well, medium fast bright meteors that often leave glowing trails that make for a nice sight. So you can go out and observe it, but if you would really like to contribute to our knowledge of this shower and others, you can record what you observed. Um, so what you can do is record each meteor that you see, label it either a lyrid or a sporadic, and you can also provide different information such as the brightness, the time, and what's very important is the viewing conditions. Um, what that really means is your limiting magnitude, which is the faintest star you can see in the center of your field of view.
Hmm.
If you can provide that, then we can correct it to someone who has a better sky than you and reduce his rates down to yours, and we can raise yours up to his, so we can compare folks that observe from different parts of the world. Most observers are going to have a limiting magnitude between 5 and 6. Therefore, the base limiting magnitude is 6.0, so they would need a correction of any meteors that they see. So what that involves is a formula. Say if you saw 5 meteors in a particular hour, that would probably increase it upward to 8. Now, someone's observing from 6.5 magnitude, we'd have to actually subtract meteors down to 6 magnitude so that we have a baseline equal for all people. And that's how we can compare them. Um, if you're thinking about watching this shower, uh, I would plan for a late night or early morning and get some sleep beforehand. And we don't want you going out there and falling asleep. Although it is very relaxing. And hopefully by April the temperature will be nice and you'll be able to enjoy the night sky. Uh, this part of the year in the morning sky, you'll have the Milky Way going from northeast down to the southwest, and it's a great sight from the northern hemisphere. You'll have the star clouds of Scorpius and Sagittarius as high as they get. And it's okay to look in that direction because you'll see Lyrid meteors coming from behind, shooting right into your field of
Wow.
view. So that's always nice.
Yeah.
And like I said, if you're able to record what you see, I I actually put it on a small recorder and listen to what I saw later on in the morning after I've gotten some shut eye, and therefore I can write it down on paper and send it in. If you could do the same and send it to me, that would be great. We could get information from all over the country and sometimes all over the world.
That'd be great. Do you
So,
have do you have a unforgettable Lyrid observing story?
do I?
Yeah.
Yes, actually, there was one time I was out in the Mojave Desert and I had beautiful skies, and I swear I didn't see one meteor in the first 2 hours I
Oh
was
my.
out. I think I saw three, and you drive all that way, you're
Yeah.
prepared, you're under the almost the best possible conditions, and nothing happens.
Well, that's
So,
not what I was looking for.
well, no, 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 I'm not finished.
Okay.
Uh, we know when we pass closest to the orbit of Comet Thatcher. What we don't know is the density of material that is in that particular. It may be very weak. So, and you know what? I have observed this shower from home where my limiting magnitude is probably only 5.5, and I have seen uh, 15 to 20 per hour from there. So
Okay.
it's a shot in the dark, like I said, but you'll never find out unless you go out. And I do have one other, a little more story that's upbeat. Okay,
Okay.
this was in 1992, and once again I was driving out to my dark sky site, and I'm seeing a meteor every minute shooting from the Lyrid radiant right in front of me as I'm driving east.
Oh my.
And I was saying, what is going on? So I get there, I throw my lounge chair down, I jump in, and I didn't see probably more than five for the next hour.
Uh,
Okay, it turns out that was one of the rare Lyrid outbursts that has happened since we really knew what was going on with the shower. Uh, after studies, we have found out that in 1802, 1862, when the comet was nearby,
mhm.
1922, and if we add another 60 years, 1982. It seems like
There you
every
go.
60 years we have an outburst of the Lyrids.
Okay.
So, folks on the East Coast were reporting Perseid-like rates with the shower much higher in the sky. Now, When I was driving out, it was only midnight or so, so the radiant was lower, and I only caught the very tail end.
Okay.
And as it turns out, people were seeing up to 60 an hour from the East Coast. So I saw a bit of that, but not, just enough to wet my whistle. And as when I jumped in my chair ready to record, and the faucet was turned off.
Oh my.
So for youngsters, though, the year the year 2040 starts a new series. We expect higher rates, probably, I would say 2042 will be the year. And but if I'm still alive,
Yeah, we'll do a podcast on
yeah, for sure,
it.
for sure. But I would say in the year 2040, that's not a shower not to be missed. So we all
Great.
have something to look forward to, but like
Great.
I said, you never know what you're gonna get.
That's true. That's true. Wow.
And before I close, I'd like to mention the next shower, which is the Eta Aquariids. Um, if you're looking toward the east during the Lyrids, you may see a very fast, long meteor shoot up from the eastern horizon. That's the beginning of the Eta Aquariids, which are associated with Halley's Comet. You won't see more than one or two an hour at this time, as the maximum occurs on May 5th. Unfortunately, we're going to have a full moon on May 1st.
Ah,
So, right when we reach the prime hours, prime dates of viewing the Aquarius, the moon is full. And at maximum, it will be 5 days past, which means it'll still be at what, 75% gibbous. So, during the first 10 days of May, which is the best time to observe the shower, it's not going to produce more than five an hour.
ah,
And to be honest, we've had great conditions the last 2 years, and it's been a dud. So there's all kinds of surprises, some good, some not so good. So, but what I can assure you is, come August, we have a new moon for the Perseids, and I can't guarantee you 100 an hour like they're going to say in the magazines and online, but if you're under dark skies, you will be highly entertained.
fantastic. That sounds great, Bob. What about resources for people that want to observe meteors? I know there's probably a book out there.
There may be a book by some guy named Lunsford. Uh,
Go ahead and plug it.
he, yes, it's called How to Observe Meteors, and it has charts just like we presented here that shows the radiance and when to observe, and it goes over the entire year, and it discusses when to watch them and how to report them, and it discusses all the major showers and many minor ones too. And there are some showers that don't show up every year, such as the June Boötids and other obscure showers, Alpha Monoceroids of November.
Okay.
So, and
Great,
we just
Bob.
had the Ta Hercules from May a few years back.
Right.
That's another one we discussed.
It's true.
So, yes, if you would like to buy my book, you'll be highly entertained.
And that's probably available on Amazon.
Amazon, any bookstores,
Great.
yes.
Great, Bob. All right. Well, I want to thank you again for coming on the podcast.
My pleasure, and we'll see you for the Perseids.
All right. Sounds good. Hi, everyone, and welcome to the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Each episode, we share the latest discoveries, observing techniques, and stories from the people who explore the moon, planets, comets, meteors, and beyond. Whether you're looking through a backyard telescope or leading professional research, we are all united under one sky. I'm Tim Robertson, your host, and thanks for being here. Now, if you're normally listening to the podcast in your car or on your phone, you can now watch it as well. That's right, the Observer's Notebook is now available in video right here on the ALPO YouTube channel. And here's another something interesting. I've noticed that over 50% of the people watching or listening are not subscribed. So take a quick second, hit that subscribe button, and ring that bell so you don't miss another episode. It's free and it really helps grow the channel. This show is made possible by support from you, our listeners. If you'd like to help the Observer's Notebook, just go to our Patreon page at www.patreon.com/observersnotebook. For $1 a month, you're supporting the show. For $5, you get early access to the podcast. For $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you're listed as a producer of the podcast. And to find out more about the ALPO, just visit www.alpo-astronomy.org, where you can join the organization for as little as $22 a year. All right, let's get into episode 231 of the Observer's Notebook podcast, and we're talking meteors. Enjoy. You can join the Association of Lunar and Planetary Observers today. It's just this easy. You can become a valuable member of this International Lunar and Planetary Astronomy Organization, founded in 1947 by Walter H. Haas. It's based upon the structure of the British Astronomical Association. You can join various lunar and planetary observing sections, contribute to our massive archive of observations. You'll have access to our extensive lunar and planetary gallery of over 20,000 photos and observations of the sun, the moon, comets, meteors, and the planets. You'll receive our quarterly publication, the Journal of the Association of Lunar and Planetary Observers. You have the ability to join the ALPO training program, which will teach you the finer points of making planetary observations. You can attend our annual virtual conference, and you'll have access to the Observer's Notebook podcast. Membership begins at only $22 a year. The way to find us, just go to your Google and type in ALPO Astronomy, and you'll see this prompt come up. There's our association with our website, alpo-astronomy.org, and you'll come to our homepage. If you look at the top of the homepage, it says Join ALPO. Click on that, and you'll come to the sign-up screen. It gives you the information on the organization, and there's two ways to join. You can join by mail, where you'll download a membership form, or you can pay online using PayPal. This is the PayPal processing page. You just fill out a few information lines, and then you're given the chance to click PayPal and join the association. Welcome to the ALPO.